Welcome to solverfy.
Okay, so we've been shown the following molecule. And we need to draw all possible stereoisomers of it, and then identify how many possible stereoisomers there are of it. So in order to do that, we'll have to identify stereocenters, right? Well, lucky for us, there are no stereocenters at sp3 carbons. That is, all of the sp3 carbons, right, those that aren't participating in double bonds, have two or more of the same substituent, and so can't be stereocenters, which leaves double bonds between carbons as our only possible stereocenters. For one of them, there are two hydrogens on one side. They're not drawn, but that's where they are, meaning that this cannot possibly be a stereocenter. On the other carbon-carbon double bond, this hydrogen existing but not drawn, we do have two unique substituents on each side, 1 and 2. Right? So this is our only possible stereocenter, and that's where our stereoisomers will come from, is this molecule drawn such that what is presently a trans double bond, trans because the higher priority groups reach across the double bond from each other rather than being on the same side, can be drawn such that it is cis. Right, so we'll redraw the molecule. With everything the same on the left-hand side of the double bond, but change the orientation of the right-hand side of the double bond such that we've now drawn a cis isomer, right? So we've got our trans isomer, which was the original, and our cis isomer, which is the one stereoisomer that we can possibly draw, right? So how many stereoisomers are possible of this compound? You can draw one additional stereoisomer, which would really imply that there are two possible. So the answer is more likely to be two than one, depending on your interpretation of the exact language. There's the trans isomer that was shown, and then one additional cis isomer possible.